I'm Dr. B, your chemistry teacher online, and today we are going to be talking about chemistry of death removal. Chemistry of death removal. Now, in some textbook, you might see it as the emulsification properties of soap, or in some textbook you might see it being discussed as the action of soap as an emulsifying agent. So whichever way it is, whether it is coming in as action of soap as emulsifying agent, or is coming in as chemistry of death removal, it is saying the same thing. Now, do not forget that as part of this class, you are expected to share this class. And if you share this class through this YouTube channel, you let your friends know that they need to subscribe so that they can get all the videos and also have videos pop up as soon as these classes come up next time. Don't forget that there is also a Facebook page, Dr. B Chemistry Classes. Once you get there, just follow, and then you can like and leave your comments in form of questions, and they will be attended to. Okay, now we are going to look at chemistry of death removal, or the action of soap as an emulsifying agent. Now the question is, what is soap all about? Soap is used every day. We use soap for personal cleaning, in terms of hygiene. You use soap to clean plates, you use soap to take your bath, you use soap to do a lot of things, you use soap to wash your clothes, and some cases they use soap also as emulsifying agents here and there. Okay, you use soap in industries as softeners for one thing or the other. You also use soap in the different areas of life. Some use soap even to remove the zip hook, okay, in your zips that you have on your clothes and all those things. So soap has a very large usage, and soap had been on and on for years. Soap has been on and on for more than 5,000 years, stemming from the Egyptian periods. They have been using soap. So soap is not a thing today, but soap during those days was always obtained from local ash and all those kind of things, where you burn some palm fruits and some palm trees parts, and then you use them to sieve and get your alkali and also all the kind of things ready. Soap from vegetable oil and some fats. But today we are using sodium carbonate to prepare soap because of the presence of technology that has brought us to that understanding. And soap today is produced from lye. Okay, you use lye, which is sodium hydroxide, all right, and then you add it to water, and then you also introduce fats, or you can call them long chain hydrocarbons, okay, large hydrocarbons from carboxylic acids. You can add them also to that, and then you heat, and then you add also either potassium or you add sodium chloride to it to precipitate that soap out, and then you do the necessary cleansing. And that is all about soap. So you can prepare soap today here, left, right, and center, and then at the end of the day you have soap to sell. Have soap for use, as the case may be. But we're not talking about how soap is prepared today. We'll look at that in another class. But today we are interested in how dirt that you have in your clothes or material can be removed when you wash. Because sometimes we are only interested in the fact that you fetch water in a container, and then you put your shirt there, put detergent, or you use soap and start washing, and next thing you see it come out bright and clean, and you dry and walk away. There is much chemistry to it. It's not enough that you just put your clothes inside water and wash with soap or detergent and it gets clean and you walk away. What is actually the chemistry behind that process is what you want to see today. What is the chemistry behind that process that leads to the cleaning of your material, of your fabric? That is what we want to see today. And now join me, let us do justice to this topic. Now I want us to know that soap, as it is, has two parts, and one of the parts is always hydrophilic and the other part is always hydrophobic. All right, not big English anyway, but I will explain what that means. So one of the parts is hydrophobic and one of the parts is hydrophilic. That is how a soap molecule is all about. So when I say soap molecule, it's something like this. Okay, so a soap molecule is something like this. This is how a soap molecule is. Okay, so this is how a soap molecule is, okay, with a COO group that is there. So the soap molecule has this part of it that is a charged head and this part of it that is the uncharged head. And this part of it, this soap molecule that has a charged head, is always hydrophilic in nature, so it is water loving. When we say hydrophilic, it means it can be solvated by water. It is water loving. It loves water, so it can be solvated by water. And it's always the charged head of the soap molecule. And then you have the uncharged head, which is the hydrocarbon part of the soap. It is hydrophobic. It doesn't like water. So when you take a look at a soap, the soap you use in washing, even the detergent you use in washing, there has two parts. One of the parts is the head, which is the charged head, and then the other part is the tail, which is the uncharged part. And the head, which is the charged part, is hydrophilic. It loves water. It can be solvated by water. And the tail, which is hydrophobic, does not like water. It cannot be solvated by water. It is not charged, and it is the hydrocarbon part. So we have the hydrocarbon part of the soap molecule. We also have the head, which is not the hydrocarbon part of the soap molecule. Now, if you understand that, you should know that when you pick soap to wash, you are gradually removing the soap molecules into the water. And as the soap molecules go into the water, it goes in with the head and the tail. The tail is uncharged and is hydrocarbon in nature. The head is what? Charged, and it is what? It is hydrophilic in nature. Now, how does it work? How does it work? Now, I want us to know that the tail, which is the tail, which is the tail part of the molecule, which is hydrocarbon, and which is hydrocarbon in nature and hydrophobic, as it doesn't love water and can be solvated by water, it loves organic parts of what? Anything that comes into that water, because the hydrocarbon itself is also an organic part. So because the hydrocarbon part, which is the tail, is an organic part, it's always loving organic parts of what? Of anything that comes into that water. And remember that dirt is organic in nature. Dirt that you find on your clothes, dirt that are on your plates, they are organic in nature, and most of the time they are oily, like grease, like palm oil, like the stew you prepare, like every other dirt that, whatever dirt that gets stick to your fabric or on your plates is always organic in nature. And by the nature of that, it is attracted to the tail part of the soap molecule you use in washing, which is what? Which is hydrophobic in nature. Alright, so when you put a piece of cloth in water, but before you do that, you used to put maybe detergent, for example, in water and agitate. Now, when you put detergent into water and agitate, what happens is that the first thing that will happen is that there must be a sort of myceli that is formed. There is a formation of myceli in that process. And what do we mean? What we mean is that once you put soap inside water, the molecules of the soap will start coming together. They will start coming together. And by coming together, it means that the tail part of the molecule, will be attracted down in deep into the water, because it's not water loving. So it will be attracted down into the water without getting attached to the water molecules. And then the ionic part of this particular soap, which is water loving, hydrophilic in nature, will be the one that will protrude up, attaching themselves to the water molecule. That is the first thing that will happen. And as they come to form that group, as they come to form this group, where all the soap molecules will have their tails facing one side deep down in the water, and the charged part, which is the head, facing up, attached to the water molecule, it forms what we call a myceli. Now, when you take your clothes that has dirt, let's say the dirt is grease, or a plate that has oil, alright, when you put it inside the water, there will be a formation of what we call emulsification. An emulsifier will be produced. Now, what does an emulsifier do? Emulsifier simply helps to do what? To mix, to allow the oil and water to mix. Remember that oil and water do not mix. They create a heterogeneous, a non-homogeneous situation. Let me put it that way. A non-homogeneous situation. So, but with the help of soap, it is going to allow the oil to be able to mix well with what? With the water, so that you can be able to do what? To detach the clothes, the material, away from what? From the oil. So as soon as this is done, now this is the piece of cloth. This is the piece of cloth, okay, while the red is the grease, let us say is the dirt. The red is the dirt and this black is the piece of cloth. So now the piece of cloth with the dirt has been immersed into the water that contains the soap. The first thing that will happen is that since the soap molecule has the hydrophobic end that does not love water but is organic in nature, it is going to first attach itself, which is the tail, to the dirt. Remember that the dirt is organic in nature, and then the tail of the soap is organic in nature, is hydrocarbon. So since the tail of the soap does not like water, it loves the organic part, which is the dirt. So the tail of the soap attaches itself immediately to what? To the dirt. While the head, which is the charge, remains hooked up to what? To the water molecule. Now, when this happens, it is now going to, as you now try to wash, you are agitating the water, you are shaking the water. So you are shaking the material, you are shaking the dirt of the material, because the dirt at this point will start fragmenting. So as you are trying to wash, you are agitating the water and the material. So the dirt will start fragmenting. By fragmenting, I mean it will start breaking into little portions. So as the dirt starts breaking into little portions, the tail, which is the hydrophobic part of the water of the soap molecule attached to the dirt, will start dragging the dirt out of it. Since it's attracted to it, it will start dragging the dirt out of it. And remember that the dirt will not be able to be stable on the material, in the sense that the soap is already creating an emulsification between the dirt itself and water. Right? And then the soap is already forming globules because of the ions that are attached to the water molecule, being hydrophilic. So at this point of your washing, agitating the water, the dirt will start breaking into pieces, we call fragmentation. And once that happens, the tail part of this particular soap molecule, which is hydrocarbon and hydrophobic, will attach itself to those dirt, because they are organic in nature, and start pulling them to it themselves. And as they do that, this is what you see. So you see that the tail part of this water molecule, of the soap molecule, has started pulling what? Pulling the dirt, which might be in any form but organic in nature, to itself. Now, as it pulls itself, the dirt to itself, it's attracted to it. And once it pulls itself to it, it surrounds the dirt with so much of the tail part of the soap molecule. So it attached itself to it. So you can see here that the dirt is removed from the material already, and the tail part of the soap molecule is attached to it. It surrounds it, and by that it forms what? A globule of dirt. Globules of dirt surrounded by soap molecule. You see, so the globule that is formed is now that the tail part of the soap molecule has surrounded the dirt all round, forming a globule. And because it forms that globule in water, it allow the dirt to mix with the water, and by so doing, the material is up without the dirt. But why is it that we do not have a redeposition? Because ordinarily one will have expected that since the dirt is now dissolved inside the water, forming emulsion, you will have expected that the dirt will go back and accumulate on what? On the material. But it's not true. It is not so, because the water molecule, remember that the soap molecule has a charge head, which is what? Hydrophilic. So it loves water, and all the charges are what? Negative. Now, because the charges are negative, and then they are attached to the water molecule, in between each of the globules of the dirt surrounded by the soap molecule, there is a charge head. So as you see your water with dirty water foaming and all those kind of things, you should know that in between each of these globule of dirt surrounded by the soap molecule, by the hydrophobic and of course the hydrocarbon part, it is surrounded also with what? The charges from the head, which is the water loving. So each of these particular soap, this particular dirt molecule has a charge from the water molecule, from the head of the soap molecule in between them. And because of the charges that stand in between them, it is difficult for you to have this particular soap molecule, this particular dirt globule, removed and passed through to come to the material. You understand? So the dirt is already surrounded with what? The hydrocarbon part of what? Of the soap. And since it's surrounded by it, it forms a globule. As it forms a globule, which is kind of a cyst that is formed around it, there is also the charged head of the soap that stands in between each of these particular dirt molecule that is formed. And because of that, it cannot detach itself from there. It's well attracted to it. There is repulsion, of course, between each of these dirt molecules because of the presence of what? Of the charges from the head part of the soap. So this repulsion that exists between this dirt molecule or globules of dirt surrounded by soap and the charge from the head of the soap standing in between these globules cannot allow the dirt to withdraw themselves and bring themselves to the material to redeposit. And that is why you are able to see that when you wash a plate where there is soap water, you can remove the plate up and it's clean without the dirt. The dirt rather is meant to dissolve in the water by the process called emulsification, and then you can throw away. Now that is just the way the soap, the cleaning of a plate, of a fabric, of anything you are doing at all with soap works. So the first thing is formation of mycelium when the soap molecules are made to get free into the water, and then there you drop your fabric which has a grease or oil or anything at all like a dirt, organic in nature, into that water. The dirt attracts immediately what? The tail part of the soap molecule, which is what? Hydrophobic and hydrocarbon in nature. Now the dirt, because it's organic and because the hydrocarbon part is organic, they attract themselves, have that strong attraction. Now when that happens, as you agitate, there is fragmentation or breakdown of the dirt on that material, and subsequent what? Attraction by removing, okay, of the dirt on the material. And then further agitation will now do what? Will now bring that process where you have globules of dirt molecules or of dirt being formed or surrounded by soap molecule, and then charges from the head part of the soap standing in between all these globules, not allowing them have any form of attraction back to what? To the material that it was removed from. So in that way you can, and when you rinse, while you are rinsing, is to what? Completely do what? Remove the emulsifier remove the emulsifier, of course, which is the soap that you have used from what? From the material, and give the material a clean wash. Now that is the way to which dirt can be removed. So when someone asks you to explain how dirt is removed from a material, or asks you to explain the action of soap as an emulsifying agent, this is all that is required. I want to believe that you have enjoyed this part of this class, and it's been a wonderful moment trying to explain how dirt are removed from a fabric in the process of washing using soap, as we normally do every day. Do not forget that this class is expecting you to do what? To like, to share, to comment, and please, as you share, tell your friends to subscribe so that they can